Hi, y'all. We're going to talk about vector addition and a little bit of vector subtraction today. So I introduced vectors in a previous lecture. Hopefully you guys watched that. But here we're going to see how to add them together, what happens when we add them together. So we've got two vectors on the screen, vector A and vector B. And the way we add these together is we just move B so that its very end, its tail there, matches up with the tip of A, and that'll be demonstrated here in just a moment. When we do that, we have to make sure that we don't change the length of B, and we don't change the angle that it's canted at. So we basically keep its position, or keep its size and its direction the same. So we've done that. Oops. Connected A, or connected the tail of B to the tip of A, and then if we go from the very start of A to the very end of B there, well, we have vector C. All right. We can also do this, so what we've seen here is a graphical addition. We can also do this in using a vector component, or using components as well. So we can break vector A down into its x and y components. We can break vector B down into its x and y components. And then if we add those x components together, they'll give us the x component of C. If we add the y components together, and in this case we see that the y component of A is positive, the y component of B is negative, so it actually, B sub y would end up taking some of A sub y's magnitude off, then we would get C sub y. And we can use these equations down here at the bottom of the screen in order to add up vectors in component form. Right. Main thing I want to focus on right now, though, is just some graphical addition. So I'm going to give a couple of examples. So say we've got vector A right there, and maybe we've got a vector B that looks, I don't know, maybe something like this. And if I want to add vector A to vector B, or add vector B to vector A, it doesn't really matter which one I move, just as long as I make sure that the tail of one goes to the head of the other. So I'm going to move vector B over here. I'm going to do my best to try to draw the same kind of shape. There we go. And then vector C would go from the end of A, or from the beginning of A to the end of B. Okay, so there's vector C right there. All right. Let's look at another example. Okay. Let's say that this time, maybe I've got vector A, maybe something like this. Maybe I've got vector B, something like this. And then maybe I've got a vector C that looks something like this. Well, what if I want to add all three of those together? Well, in that case, let's see, I would move B so that its beginning, its tail starts at the tip of A. Okay, and then I would move vector C so that its beginning goes at the very end of, whoops, goes at the very end of B there. All right. And then I have to choose a different color. My resultant vector, my resultant vector would go from the beginning of A all the way to the end of C. Okay. And so we could call that resultant vector, I don't know, maybe we would call it something like R for resultant. So that's how I would add three vectors together. And it's a little messy because of the individual vectors that I chose, this way, that way, and this way, or something like that. I can't remember if the camera's mirrored or not. But that's basically how we do graphical vector addition. Now, ideally, we would have a ruler, and we would make sure that our links are all correct, and so on and so forth. And we would have maybe something to measure the angle there and make sure that the angles are all right. But doing this can give us some pretty good ideas, some pretty decent sketches of what our vectors end up looking like when we add them together. All right. What if I want to subtract one vector from another? Well, here I've got vector A and vector B. So in order to subtract B from A, what I do is I flip that vector B by 180 degrees. Basically, I just spin it around so it's pointed in the exact opposite direction. All right. And then I move that over so that, and this should be there should be a negative sign in here. Apparently my pen went away. There should be a negative sign right there. Pen still went away. There we go. Negative sign. So if I, so I move that that vector B over so that it starts right where vector A ends, and then again I draw my resultant vector so that it goes from the start of A to the end of negative B, and there we go. I've got A plus a negative B is equal to C. So this is literally A plus negative B equals C, or that would be A minus B equals C. All right. What happens if I've got something like this, where I've got, it looks like I've got a scalar multiple of a vector? Well, this works exactly the way you might think. I just double B's size. There's 2B. Or is it not 2B? I guess that's the question. Okay, so we move 2B over so that its very start matches up with the very end of A, and we draw in vector C so that again it starts at the very start of A and goes to the very end of 2B, and there we've got A plus 2B is equal to C. All right, so this was a little graphical addition. We are going to do some addition by components as well, but we'll cover that at another time.